Okay, good day, sir. Good day, classmates. My topic is about data processing and statistical treatment. Okay, at the end of this lesson, the students should be able to define what is data processing and statistical treatment, apply appropriate statistical concepts, methodologies, and technologies in organizing, analyzing, and interpreting various real-world situations, and in coming up with relevant decisions. Okay, what is data processing? It is a means of converting information either manually or by machine into quantitative or qualitative forms for use in research analysis. Okay, once the measuring instruments have been retrieved, the next activity of the researcher is to process the raw data into quantitative and qualitative forms. They are both involved in data processing to arrive at precise analysis and interpretation of the results. Okay, data processing involves input, throughput, and output mechanisms. Input involves the responses to the measuring instrument of the subject of the study. Throughput includes the statistical procedures and techniques. Output is the result of the study which are presented in the data matrix form. Okay, we have three basic steps in data processing. First is the categorization of data. It refers to the grouping of subjects under study according to the objectives or purpose of the study. Example, the main purpose of the study is to determine the problems met by science and mathematics instructors and professors in a certain state college in relation to administration and supervision, instructional materials, teacher factor, and student factor. Okay, the subject may be categorized as a whole, as science and mathematics mentors, as qualified and non-qualified, according to performance, and in terms of experience. Okay, we have 5 rules in categorizing research information according to Kerlinger. First, categories are set up according to the research problem. Second, the categories are exhaustive. Third, the categories are mutually exclusive and independent. Fourth, each category or variable is derived from one classification principle. And fifth, any categorization scheme must be on one level of discourse. Okay, the next step in data processing is the coding of data. Okay, coding of data is the process of deriving codes from the observed data. In qualitative research, the data is either obtained from observations, interviews, or from questionnaires. The purpose of data coding is to bring out the essence and meaning of the data that respondents have provided. Example, if the number of categories in variable is 30, then the numerical codes should have 2 digits such as 01, 02, up to 30. Okay, the third step in data processing is the tabulation of data. Okay, it involves tallying and counting the raw data to arrive at a frequency distribution and to facilitate in organizing them in a systematic order in a table or several tables. Okay, tabulation can be done either manually or by machine. In manual tabulation, data are manually tallied by hand or for small number of cases only. In machine, the total number of cases is more than 100. Okay, data matrix. Presentation of data is usually in tabular form, and this is called data matrix, and data processing output is either quantitative or qualitative. Okay, 3 types of data matrix. First is the univariate matrix, the bivariate matrix, and the multivariate matrix. Univariate involves only one variable. A variable in univariate analysis is just a condition or subset that your data falls into. You can think of it as a category. For example, the analysis might look at a variable of age, or it might look at height or weight. Okay, we have a scale here. 1 means inadequate, 2 fairly adequate, 3 adequate, and 4 is very adequate. Okay, example, mentor perceived adequacy of instructional materials at 4 levels of SUC. Okay, we have here level of SUC, the mean, and the descriptive interpretation. Okay, 1, example, the mean is 3.6, means very adequate. 2, and the mean is 3.4, means very adequate. 3, and the mean is 2.9, means adequate. And 4, and the mean is 2.8, means means adequate. And next is the bivariate matrix. The bivariate involves 2 variables. Example, number of absences and quiz grade. And multivariate matrix has 3 or more variables in the table. Example, number of absences, quiz grade, and recitations. Dummy tables. Dummy tables are helpful in preparing for the data matrix because they are used in planning, summarizing, organizing, and analyzing the data on how the different variables differ with each other. Dummy tables are almost similar with the real tables, except that only the total number of variables, total number of cases, and percentages are presented. Unlike real tables, the frequency, mean, percentage, descriptive interpretations, and totals are shown. Okay, we have here an example of dummy tables. Okay, when we say dummy tables, hindi pa siya na-organize. So, kailangan pa siyang i-organize or i-arrange. Okay, next is the statistical treatment. Okay, it is a summary of the procedure including statistical methods used. The authors read various theses and dissertations in which the researcher used percentage in scales used similar to that in the foregoing problem. This is a common error of researchers. For comparison purposes, of correct and incorrect statistical tools used in organizing the data. Okay, we have a formula here. This is a formula of mean or formula of weighted mean, where x is equals to weighted arithmetic mean, and summation of fx is equals to the sum of all the products of f and x, where f is the frequency of each option and x is the weight of each option, and summation of f is equals the sum of all the subjects. Okay, the percentage formula is as follows. Okay, we have here percentage symbol is equals to f over n times 100, where percent symbol means percentage, f is frequency, and n is the number of cases. Okay, schematic presentation. It is not enough that a researcher formulates only one research problem in his study, but preferably 2 or more to be able to test the significant difference between the responses of the subjects. In scientific research, there is a statistical tool for every research problem. Okay, example, independent variable. In independent variable is the science and mathematics mentors, and in dependent variable, the level of SUC's instructional materials. Okay, schematic presentation of univariate matrix variable on the adequacy of the instructional materials as perceived by science and mathematics mentors in the different levels of SUCs. Okay, independent variable is the qualified mentors and non-qualified mentors. The dependent variable is the level of SUCs instructional materials. A schematic presentation of bivariate matrix variables on the adequacy of instructional materials as perceived by science and mathematics mentors in the different levels of SUCs. Okay, another one, independent variable is the salmon style, Spanish style, French style, and Japanese style. The dependent variable is the acceptability of canned milk fish. Diagram of multivariate matrix variables on the acceptability of canned milk fish in salmon, Spanish, French, and Japanese styles. Okay, of 3 examples of matrices, it is only in the univariate matrix problem that testing of the significant difference of the response of subjects cannot be applied because only one variable is involved. Okay, statistical tools to test the significant difference of the variables. Testing the significant difference of variables is applicable when 2 or more variables are involved in the study as bivariate, multivariate matrices. Okay, we have a formula here. X r squared is equals 12 over nk to the quantity of k plus 1 times summation of r squared minus 3n to the quantity of k plus 1. Your xr squared is equals to Friedman two-way analysis of variance. N is the number of rows, k the number of columns, and r sub I is the ranks in the ith columns. Okay, statistical tools to test the significant difference of the variables. Okay, to test the significant difference of the multivariate matrix, okay, we have analysis of variance or ANOVA. Okay, to test the significant difference of the bivariate matrix, we use t-test, chi-square, Spearman's rho, and z-test. Okay, statistical tools to test the significant relationship of the variables. Okay, we use correlation coefficient. Okay, statistical tool for research design. Okay, to determine the correct statistical tools to be used in the study, the researcher should diagnose carefully the specific problems and the measuring instruments. Okay, some suggested statistical tools for descriptive design are the chi-square, Friedman's two-way analysis of variance, Kruskal or Wallis one-way analysis of variance by ranks, correlation, pooled percentages, and z-score. Okay, chi-square is used to compare the differences of 2 or more variables with data that can be readily transformed into frequencies. Okay, we have here a formula for chi-square where x squared is the chi-square, e is the expected frequency, and 0 is the observed frequency. Okay, the suggested statistical tools for experimental design are the t-test, analysis of variance or ANOVA, and correlation. A t-test is used to determine 2 variable means which differ significantly. Okay, we have a formula here for the t-test where t is the value, e is the expected frequency, and o is the observed frequency. Okay, data analysis and interpretation. Data analysis may be defined as an examination of data or facts in terms of quantity, quality, attribute, trait, pattern, trend, relationship, among others, so as to answer research questions which involves statistical techniques and procedure. Okay, the basis in analyzing research data are specific problems or objectives, hypotheses, measuring instruments, and statistical tools. There are 10 types of data analysis. Number 1 is the univariate analysis. Number 2, bivariate analysis. Number 3, multivariate analysis. Number 4, normative analysis. Number 5, status analysis. 6, descriptive analysis. Number 7, classification analysis. Number 8, evaluate analysis. 9, comparative analysis. And 10, cost-effective analysis. Okay, univariate analysis This type of analysis tests a single variable whether the variable is similar to the population from which it has been drawn. Bivariate analysis tests two variables on how they differ with each other. A common statistical tool to be used in bivariate analysis are correlation coefficient, which is used in descriptive and experimental design, the z-test, and the t-test is used in experimental design. Then multivariate analysis, this type of analysis tests three or more independent variables at a time on the degree of relationship with the dependent variable. Okay, statistical tools which may be used in this type are ANOVA or analysis of variance for experimental design, the Friedman two-way ANOVA including Friedman and Kruskal-Wallis ANOVA, and chi-square for descriptive design. Bear in mind that the Friedman and Kruskal-Wallis ANOVA are applicable both for experimental designs. Okay, normative analysis. The result of the study is compared with the norm. The statistical tool which may be used for this type are arithmetic mean and standard deviation. The status analysis stresses real facts relating to current conditions in a group of subjects chosen for study. The common statistical tools which may be used in this type are arithmetic mean, standard deviation, and z-test for the difference between means. And the number 6, descriptive analysis, merely describes the characteristics, composition, structures, substructure that occurs as units within the larger structure. The statistical tools commonly used in this type are the arithmetic mean, chi-square, and Friedman two-way ANOVA. A classification analysis. This type of analysis is usually employed in natural science subjects such as botany, zoology, biology, psychology, etiology, conchology, and the like. The statistical tools may be used in this type are mean and t-test are used to test the significant difference of the means. Number 8, evaluate analysis. In this type of analysis, appraises carefully the worthiness of the current study. The statistical tools that commonly used in this type are the weighted arithmetic mean, percentages, Friedman's two-way ANOVA, and z-test. Number 9, the comparative analysis. In this type of analysis, the researcher considers at least two entities or not manipulated and establishes a formal procedure for obtaining criterion data on the basis of which he can compare and conclude which of the two is better. Okay, the common statistical used in this type are mean, variances, and t-test. And the last one is the cost-effective analysis. In this type of analysis is applicable in comparing the cost between two or more variables and to determine which of the variable is most effective. Okay, in other words, cost-effective analysis, the researcher should determine which of the variable is more economical and effective. Okay, that's all. Thank you.